Saxon Algebra 1, Lesson 21. Product rule for exponents. You guys, this is a rule that I like a lot. We're going to talk about these 3 rules for exponents until you're sick of hearing me talk about them. But they're really cool and super helpful. And we will, excuse me, I'm yawning. And we will use this rule a billion times. So settle in and enjoy. The rule works like this. If you have 2 bases that you're trying to multiply together, remember the base is the main number, and they have exponents on them. Okay, so I'm just, when we're trying to describe a general rule, we usually use letters instead of numbers so that you understand this works for any combination of numbers. So the bases must match, but they can be any number or letter, and then the exponents can be any number or letter. The main thing that I want you to understand is that you can simplify that by adding the exponents. Okay, so this little expression here illustrates the rule. When you're multiplying matching bases, you can add the exponents. That, my friends, is fabulous news, and I want you to write that in your cover right now. I'm going to sit here and stare at the wall for 10 seconds while you copy that into your cover and burn that into your brain, or at least start. Okay, I literally counted to 10 slowly, so I hope you got it done. If not, pause me again. Okay, let's see how this product rule works. The first problem looks like this. Copy, please. Okay, notice what's happening here. We have 4 factors, they're letter factors, but that's okay, being multiplied together. They each have an exponent. 2 of the exponents are x's, and the other 2 of the factors are x's, and the other 2 are y's. What that means is that we can take the bases that match and combine them. So this is the way that I this is the way that I'm telling you to do these problems. First, we're going to consider the base of x, and we're going to add the exponents. So it's 2 plus 5, which is 7. So that means in our answer, we're going to have x to the 7th power. There's where I calculated the exponent. There's the base that it goes on. And then our y will have 2 plus 3. And so our y term, which again is still being multiplied, but now it has an exponent of 5. And that's the right answer. Again, you guys, I teach you these ways to lay out the problem because I know what's coming, and I know that it's going to get way more complicated and crazy. And while you could very easily add 2 plus 5 in your head and then 2 plus 3 and just write it down, the day is going to come when this is wild and you're going to be like, I can't carry all of this detail in my head. And you're going to wish, if only my math teacher had taught me a way to write this down so that I could make sense of it when it was difficult. You're never going to have to say that because here we are, you guys. We're doing it from the beginning. So trust me and use this process. Next problem. This is like a 7 example lesson. Kind of long in that respect, but it's okay. We'll cruise through it. Example 21.2. Here we go. Simplify. Okay. I recommend that when we're doing problems that are heavy fraction or exponent problems, you need to find a way to make sure that your bases are a considerably different size than your exponents, but your exponents are still legible. This can turn into a mess so quickly, you guys. and it's really easy to make mistakes. So what I do, and again, I'm trying to make sure you can see it, so that's a little different because you're not necessarily filming your homework for, excuse me, yawning again, for other people to watch, but I would still do it because look how much easier it is to tell the base from the exponent. Okay, let's use our rule again. We're gonna go, let's go alphabetical. M doesn't have anything, so we don't need to even write that down. We just say, okay, here's our answer, m to the 5th. X, we're gonna have 2 plus 3, that's x to the 5th, and then y is going to be 3 plus 2. So that's y to the 5th also. All right, and this is correct. Okay, 21.3. Simplify. X, y squared, x to the 3rd. There's that needle being dragged across the turntable again. What are we supposed to do about these? They don't have an exponent. Well, here's the thing. We can add an exponent anytime we want. And it's a 1. Write this down inside your cover too. If you ever have a letter or a number with no exponent, but you need to use the product rule, you can pop in a little exponent of 1. It's true for the other rules we're going to use as well. Anytime you have a base with no exponent, you can add a 1. All right, so we're going to go right in and fill those in. Now we can do x is 1 plus 3, and that's x to the 4th, and y is 1 plus 2, and that's y to the 3rd. That's correct. This was correct also. Make sure you get that. That's one that students forget all the time. They just think, oh, if there's no exponent, I don't have to add it. False belief. Don't make that mistake. Please, I beg of you. Think of a new mistake to make, but don't make that one. All right, example 21.4. Oh, it's a long line, you guys. Are you ready? M cubed. P, M, X, M. M is squared. X to the 3rd, P to the 5th. Okay, so the trick on this one is the same trick as last one. We just have to be really careful that we fill in all these blank dudes. I'm making sure I copied it correctly too, because that would be a problem, wouldn't it? The M squared, X to the 3rd, P to the 5th. Okay, so let's go. Again, this is a great time to remember our alphabetical order thing because it's easy to make sure, it's a great way to make sure that you're not forgetting any of the variables. So let's go alphabetical. We'll do M first. Oh, let's do this though. Let's fill in ones where we don't have an exponent. M is 3 plus 2, so that's M to the 5th. P is 1 plus, oh wait, look at that. 3 plus 2, 3. M has 3, 2, and the 1. So this should be a 6. Okay, P's 1 plus 5. So P is also to the 6. And then X, 1 plus 3. Right. John writes these in a different order. He has the same exponent by each base, but he writes the exponent or the bases in a different order. That's fine because they're all being multiplied, so it's no biggie if we have a different order. What's important is that the letters have the appropriate exponent on them. So we did good. Okay, now what we're going to do is up our game just a little bit by adding together multiple terms like this. All right, so I'm going to do this once the way that I would not like you to do it for your homework, and then we'll do the last two problems the way I would like you to do it. Or I'll explain it to you. The first one looks like this. The last term, I'm going to write it up here so I don't have to squish it. Minus 7 okay, I'm going to look through it again just to make sure I got it right. X squared yp to the 5th plus 2xy squared. This should be a 2. P to the 5th plus 3 p to the 5th x squared y minus 7y squared xp to the 5th. Now, within each one of these terms, we have just the same, we don't have any multiples of the same base, right? xyp, 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 xyp. I'm not saying them in the right order, but it's just the same letters. So we don't have to use the product rule to clean anything up within each term, okay? We cannot use the product rule to add these, right? We could use it to clean up within each term if there were multiple of the same letters, but we can't use it to combine them because the product rule, here it is, it only works when we're multiplying, not when we're adding. And students get confused about that because they remember the adding up here and get kind of, they kind of go a little crazy and think, yeah, there's adding in the product rule, it's fine. No, the product rule only works when you're multiplying the bases. So we could clean things up if there were multiple in there, but there aren't. So the key to this problem is to say that before we can do any of these addition and subtraction operations, we have to see if these terms match. They have to be like terms, right? So what we want to do is see if they match, and the best way to do that is to put them in alphabetical order, the terms in each one, and make sure the exponents are correct, right? They have to go properly. But that way we can see whether they're going to match or not. So I'm going to go alphabetical. P to the 5th, second, I want that to be a little bigger. P to the 5th, x squared y. That's the first one. There's no numeric coefficient on it. Plus 2 p to the 5th, x y squared. That's not quite the same, is it? So I'm going to check my book and make sure I copied that right? Because I don't want to make a silly mistake. Nope, I copied it correctly. after I fix that. They don't match. They're not exactly the same. Interesting. Okay, let's go on. 3 pxy, that's the right order. P to the 5th, x squared y. We go, oh, look, that matches this one. And then 7 minus 7, p to the 5th, x y squared. Okay, so we look carefully and we see, look, this one matches this one, and this one matches this one. So we can combine the numeric coefficients on those two, but if the letters and exponents don't match, then no bueno, they can't be combined. So I'm going to add these two together. This one does not have a coefficient, so I'm going to give it 1. It's always a 1, right? So I have 4. Gracie's hearing somebody rattling a doorknob, and she's not having it. X squared y, and then plus 2 and minus 7 is minus 5. Good girl, Grace. P to the 5th, x y squared. That is our final answer, and that is correct. Okay, what I am going to suggest to you is that if you're doing the homework, you don't even want to write it down the wrong way. Just correct the order as you copy the problem out of the book so that you get right to this as your starting stage. All right? Remember, all we did was just put them in alphabetical order. This is one of those times when it's so worth it to put your terms the variables in each term into alphabetical order so you can compare and see if they match. Okay, let's do another one. I'm going to continue to write the wrong terms the way John has them in the book because I want you to see them. But again, if I were you doing the homework, I would not write it this way. Okay, 4 terms and they are long. 2m3. Copy with me, please. Okay, again, this is the 4th term. It should be out here, but I ran out of space, so I just went up there. I'm looking again to make sure I got it right while you finish copying. Beautiful. Okay, that's what the book says. If I were doing this problem in my homework, I would rearrange each term as I wrote it down. So I would go 2, let's see, it's MPXY is alphabetical. So M to the 3rd PXY squared is the better version of that. Rearranging this one, plus 3 M to the 3rd PXY squared. Look, we have a match. Exciting, right? It always feels good. Feel like you're doing something right. Minus 10 m to the 3rd pxy squared. More dog alerts coming in. And then this 4th term, I'll write here, plus m to the 3rd px squared y. Whoa, we have a freak child. We have a freak child right there. And I'm double checking again just to make sure I didn't copy that wrong. But no, that's the way it's different, right? Because this, we have m to the 3rd p x, 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 and an x squared. And then the y's are off too. Y squared, y squared, y squared, and a plain y. So these guys all match, and we can combine them. This one is, sad to say, the misfit. I mean, there's nothing wrong with this term. It just doesn't go with the others. So no offense, little guy. I'm not shaming you. You just can't be combined with them. So now I can look to my numeric coefficients. 2 plus 3 is 5, minus 10 is minus 5, and then I copy the letters. M3 pxy squared, and then this dude just hangs out at the end. And that is our final answer. Okay? Ta-da! Don't you feel smart? These are long, complicated problems. And now here's one more, last one of this lesson. Here we go. 2, oh, I want to make it bigger. 2x squared y. Okay, these are almost all in the proper order, aren't they? X squared y, this would be 3x squared y if we wrote it the right way. I'll just rewrite as we go through these. That one was the same. This one, I flipped those around. This one looks good. This one looks alphabetical. Okay, now I notice these guys don't have numeric coefficients. If you like, some students like to put that in right away. Fill that in and make sure that we know there's a 1 there so that when you go to add and subtract, you've got matching dudes. All right, let's do the x squared y's. X squared y, and then here's an x squared y squared. It's really nice, you guys, to use multiple colors. Like I have these handy, but I'm not using them. to underline the different terms that match with each other. But even if you're too lazy to pick up a different color, which sometimes I am, I mean, literally I have all those markers sitting right here, but I'm not using them. Just make different kinds of underlines or circle or whatever. It helps so much to slow yourself down so you don't make silly mistakes. Okay, so now I'm gonna add all of this. It doesn't really matter which you do first. So I'm gonna start with this one just because it's first. 2 plus 3 is 5 minus 1 is 4. X squared y, I copy the letters. And then the squiggles are 1 minus 4, so that's minus 3 x squared y squared. And that's the right answer. Okay, so in order to add and subtract terms, they have to be exactly the same, not only the base letters, but also the exponents. So there's a little exercise in making sure they match. Okay, lesson 21, all done. Thank you, bye.